Okay, so this is going to be our second lecture, that is about kinematics. In kinematics we study about the motion of an object. So we will study how it is moving, and we will not be discussing why is it moving. Like, we don't need to know what is causing the motion. We will just talk about how it is moving and what is the behavior of motion of an object, like what is the distance, what is the displacement, what is speed, what is velocity, and how is it moving, how much is it moving. But we don't need to know why is it moving. We will be discussing it in the dynamics part. So in today's lecture we will be discuss everything about motion. So first thing that you need to know about is distance, displacement, speed and velocity. We discussed about distance, displacement, speed, velocity in our last lecture. We will go through it again in a bit of details. So the first thing that you need to know about distance is that it is the total path of length, like the total path that an object or a person takes to go from point A to point B. If you want to go from point A to point B, then the total path would be like you will go from this street and this street, and then you will go from a park, and then you will go from a sea, and then you will reach point B. But what if I tell you that you can go straight from point A to point B? Then that is the shortest path that you took, right? So displacement is the shortest path that you take to go from one location to another location. So distance is the total path and displacement is the shortest path between 2 points. We talked about that displacement is a vector, so that's why we use a vector sign on it. While distance is a scalar quantity, so we don't use a scalar unit on it. The one thing that you need to know is that the distance and displacement could be equal. Like for example, if these two houses, like your house and my house, is in a desert, then you don't need to go from streets and parks and graveyards to reach my home. You will just walk straight from my house to your house, right? So in a linear motion, in a straight path motion, the distance and displacement can be equal, like this. This is possible, but in most cases distance is always greater than displacement, but in some cases distance could be equal to displacement. So it can also be written down as distance divided by displacement is equal to or greater than 1. So you can also write the equation in this form. Let me write it down in a box like this. So now you know like what is distance, what is displacement, and how they are related. Let's move on to speed section. What is speed? Speed is nothing and just distance covered per unit time, like how much distance you cover in a specific time is called speed, and velocity is how much displacement you cover in a specific amount of time is called velocity. As same we talked about, speed is a scalar quantity and velocity is a vector quantity, and the same relation could be written down for speed and velocity. Speed could be equal to or greater than velocity, but velocity can never be greater than speed, or you can say displacement can never be greater than distance. Similarly, you can write down as speed divided by velocity is equal to or greater than 1. So this was the relation between distance, displacement, speed and velocity. So let's move on to our next topic, that is about rotation. For example, if a question is asked about distance and displacement in a circular path, so these kind of questions are a bit tricky, so we will be using some short trick formulas so that you can memorize or solve these questions in a much more easier way, or you can say in a bit tricky way, so that you don't need to memorize or be really hectic about solving these questions. So don't get confused. So the first thing is that, for example, this is point A, point B, point C and point D. But if I tell you that you have to complete a run from this lap, like run from point A and back to point A, if you run a complete lap here, then you will cover a whole circumference of a circle. So the distance would be 2 pi r, right? That is the formula for the circumference of circle. What about displacement? If you want to go from point A to point A, then the shortest path would be that you don't go anywhere at all, like keep standing where you are standing. So the displacement would be 0 because the shortest path from point A to point A is 0, right? You don't have to go anywhere. Let's talk about distance for 1 by 2, 1 by 3, 1 by 4th. So first of all, let's talk about half of the distance. For example, if you want to go from point A to point B, and for this, as you can see, it would be like half of the circle, and if it is half of the circle, then the formula would be half of the circumference. So if we take half of the circumference, then the answer would be pi r, right? 2 pi r divided by 2 is pi r. And if I tell you that if you have to go from point A to point B, that would be like 1/4 of the circle. Like if you divide the circle into 4 parts, then this would be 1/4 of the circle, and from point A to point B it is 1/4. So to get 1/4 of a circle, multiply 1/4 with 2 pi r. What you will get? You will get pi r divided by 2, right? And if you want to get 3/4 of the circle, like if you want to go from point A all the way to the point C, so it would be like this, right? So it would cover the 3/4 of the circle. So you will multiply 3/4 with 2 pi r. You will get 3/2 pi r, right? So these are all the formulas you need to find the distance in a circle. We have written it down in that table, so it is really easy if you get used to this formula. They are really easy to use, but if you like solve them individually, then they are really hectic and there are a really big headache, but I made it really easy for you. The next thing is about displacement. For example, if you want to go from point A to point B, then this is the not shortest path, like this is a circumference. The shortest path would be this, right? This is not the short path, this is the short path. So to find the displacement, you need to know Pythagoras theorem. You know, this is the radius of the circle and this is also the radius of the circle, right? And the formula for radius or hypotenuse is using Pythagoras theorem. Pythagoras theorem says hypotenuse equals base square plus perpendicular square. Base is radius and perpendicular is also radius. You will get r square plus r square under root. You will get under root 2r square. You will get r under root 2. So to go from point A to point B, the formula is r under root 2. Simple, right? And if you want to go from point A to D, what can you do? Can you tell me? It is really easy, to be honest. Like, it is just common sense. You can use common sense to derive this formula. So if you want to go from point A to point D, it is half of the circle, right? So if you can see, it is simply the diameter of the circle, or you can say 2 radius of the circle. So the answer is double the radius or the diameter of the circle. And if you want to go from point A to point C, then this would be the answer, right? So you can use the same formula as we used before. You can write it down again. The answer would be same. It would be r under root 2, right? So these were all the answers that you needed to know. The options were r under root 2 because you want to go from A to B, and the same should be for A to C, right? You will also get the same answer, that is r under root 2. And for half of the circumference or half of the circle, you need to know the formula, that is 2 of the radius. So these were all the formulas that you need to know about distance and displacement in a circular path. So if you get any kind of MCQ that is about if a person is running or a car is taking turn, then now you know that how to find a distance and how to find displacement in a circular path. So it used to be really hard, but now it is really easy, right? So next thing is about combined velocity. You need to know about the formula for combined velocity, that is m1 v1 plus m2 v2 divided by m1 plus m2. This is the formula for combined velocity. We don't be going into the derivation of these formulas because derivations are really long and it will take a lot of time. So you just need to memorize the formulas so you can just use them in the final exam. Believe me, we will cover all the formulas that you need to know for IMAT exam, but you don't need to know about the derivations, because derivations are really long and there is no point in learning and memorizing derivations because they are irrelevant for the IMAT exam. So what about this formula? If you can also be write it down as, you can see m1 v1 plus m2 v2. So mv is the formula for momentum. You can also write it down as first momentum and second momentum divided by m1 plus m2. Like, what do you mean, brother? What are you talking about? This is not making any sense. So this formula is used if an MCQ is about how to find the combined velocity of two objects. Like if there are given two objects, if it has mass 1 and mass 2, and the second moving with velocity 1 and velocity 2, then they ask you about what is the combined velocity of these two objects, then you can use this formula, and it is really easy. You can just memorize it. Is like sum of momentum divided by sum of their masses. Simple. Sum of momentum divided by sum of their masses. You can find the combined velocity. The next thing is about the relative velocity. It is one of the most common questions that is asked from this chapter, not in just IMAT but in all the exams that you can see for medical entrance exam. Relative velocity is one of the most important concepts. So for example, two people or two objects are moving in the same direction like this. This is object 1 and this is object 2. So they are in parallel motion. So the formula for parallel motion is v1 minus v2. This is with respect to v1. Like if you want to find velocity of v1 parallel to v2, then this is the formula, with respect to v1. Okay, so this is the formula for relative velocity for v1, and with respect to v2, the relative velocity would be v2 minus v1. Why are we minusing velocities, and what do you mean by with respect to v1 and with respect to v2? So the answer would be really simple in the diagram. For example, this is you are moving with velocity 1, and this is your friend that is also on a bike that is moving with velocity 2. And if both of you are moving in a parallel direction, then both of you will have velocities. For example, v1 is u, then if we are talking about velocity with respect to u, then we will use the first formula. And if we are talking about relative velocity according to your friend, then we will use this formula, because there is a perception of velocity. Like if he is seeing you and you are going slow, then the relative velocity would be different, and if you are moving faster than your friend and you are moving ahead of him, then the relative velocity according to you would be different. So these are the two formulas that you need to memorize for this part. So the relative velocity with respect to you and with respect to your friend is given here. So let's talk about if you are moving in anti-parallel direction. For example, you are on a train, the train is moving ahead like this, it is moving forward, right? And there is also a bird that is moving in the opposite direction. What would happen? Like both of you feel like the bird is moving faster, right? Whenever you are traveling in the forward direction and something moves in the opposite direction, you feel like, wow, that was so fast. No, the car or the bike that just crossed you was not fast. It was your perception. It was because of relative velocity that you felt it was really fast. So because they were moving in an anti-parallel direction, the relative velocity would be v1 plus v2. So the relative velocity would be simply by adding both of those velocities. So this was the formula for relative velocities if they are in anti-parallel direction. So what if the objects are moving in perpendicular direction like this? What could be an example of perpendicular direction? Like for example, if you are moving forward like this, and there is an air, like raindrop is falling from the sky, and now like these are the example for perpendicular velocities. So if anything is perpendicular, then the relative velocity formula would be using Pythagoras theorem, right? the Pythagoras theorem would be v1 square plus v2 square. Simple. So these were the formulas that you needed to know for relative velocity MCQs. These formulas are not really hard to memorize. You can see that if the objects are parallel, then you will just minus out their velocities, and if they are anti-parallel, then you will just add their velocities, and if they are perpendicular, you will use Pythagoras theorem. Don't make it really hard for yourself, like seeing like there are so many formulas to memorize. There are not so many formulas. These are just basic formulas, and you are deriving basic formulas and deriving more formulas from those basic formulas. So next thing that you need to study about is the average speed. Average speed is like one of the most difficult MCQs for students, but let's make it fun and more easier. For example, if you get an MCQ about like there are two objects and they are moving with a really high speed, and they have covered different distances, like object A has covered 100 meter and object B has covered 50 meters, but they took same amount of time, like both of them took 5 seconds to reach 150 meter, right? Then the formula would be used in this section. That would be, sorry about that, average speed, that would be v1 plus v2 divided by 2. We won't be going into the derivation of these formulas, just memorize it as it is. So if you are given two objects and they are moving some kind of distance, it could be 1000, it could be 5000, but if they have covered different distance in same amount of time, then you will this formula. What about if they have different time, like for example an object covered a different time in different distance. For example, if they have covered 100 meter in 1 hour and the other one covered 100 meter in 30 minutes, like they had different times but they have same amount of distance, both covered 100 meter but in different time, then the formula would be average speed would be 2v1 v2 divided by v1 plus v2. Don't memorize the derivations, you don't need to know about the derivation, just memorize the formulas. The formulas are really simple, so just don't mix out these MCQs, because most of the time students mix out these kind of MCQs and formulas and they get the answer wrong. So this was when the timeline is same and this was when the distance is same. So what if there are three objects and they have covered same amount of distance, right? The option would be same. Like if there are three objects, the formula would become 3 v1 v2 v3, and it would divide by it might seem complicated, but it is same as two objects. It would be v1 v2 plus v2 v3 plus v1 v3, right? This is the formula that you need to know if there are three objects that have covered the same distance in different amount of time. And if you are thinking about what if the distance is also different and time is also different, it would be simply like this. Sorry again, average speed would be s1 plus s2 plus s3 divided by t1 plus t2 plus t3. You don't need to memorize this formula because you already know this formula that's written here, right? Average speed, it would be the sum of the distances divided by sum of the time that you have. So I won't be writing it down because it is the basic one and it will make our notes look a bit of bad. I want these notes really neat and clean, so you can just come back to these notes and revise again and again. So next thing is about the sign conventions. So we won't be going into really big detail for sign conventions because most of the students know about these basics, but I will tell you that if you are going on the upward direction, the sign is positive, and if you are going into the right direction, it is mostly positive, and if you are going downward in the downward direction, the sign would be negative, and if you are going into the left direction, the sign is mostly negative. So the thing that most students get wrong is that they choose a direction and then they change their direction. For example, if you are going upward and you chose the direction to be positive, right, then you have to stick to the positive sign for the whole calculation. Like, don't change the signs in the mid calculation. Also, if you are stick to negative sign, then stick to negative for the whole calculation. For the upward you chose positive, then for like downward there would be negative. If for upward you chose negative, then for downward it would be positive. So you have to stick to a sign for the whole calculation, so you don't get the MCQs wrong in your answers, right? So we will be solving this kind of MCQs, so you will get clear about it, like what I'm talking about. So these are some example that is written in front of you. You can take a screenshot and you can study them later. So let's solve MCQs that is IMAT Past Paper. So they are saying that a vehicle has traveled east for 6 kilometers. It is a news question, like news, you know, news is north, east, west and south. It is news, right? So they are saying a vehicle has traveled into the east direction for 6 kilometers. This is the 6 kilometer, and then south for 8 kilometers, like this, without stopping. If the trip takes 15 minutes, what is the magnitude of the average velocity in kilometer per hour? So you have to take in mind that there are so many things happening at the same time. The first thing that you need to find is the average velocity, not average speed. Most of the students get these kind of things wrong. They are asking about average velocity, not average speed. Don't use these formulas here. Like, we studied about these formulas, obviously we did, but they are asking about average velocity. So what is average velocity? You tell me. It is displacement, right? Displacement divided by time, right? So first you need to find the displacement. So what would be the displacement? They have given you two pathways. The one is 6 kilometers, the other is 8 kilometers. So what could be the displacement? Like, if you want to go from point this to this, you will use a Pythagoras theorem, right? So the Pythagoras theorem would give you displacement. The displacement would be under root 8 square plus 6 square. You will get 64 plus 36 under root, you will get, when we add both of these, you will get under root 100, and it would be 10. So the displacement is simply 10. Okay, so it is in kilometers. As you can see, 8 kilometer and 6 kilometer. What about time? Time is given in minutes, like it is 15 minutes. So you have to convert minutes into hours. So to convert minutes into hour, what would you do? In 15 minutes, 15 divided by 60, you will use 15 divided by 60. So the time is, the displacement is 10 kilometer, and the time is 15 divided by 60, and you will get hour. So average velocity would be 10 divided by 15 divided by 60. 60 will go up and it will multiply with 10, it will become 600 divided by 15, and if we solve it, you will get 40. So the answer is 40 kilometer per hour. So it might seem like look really easy, but most of the students get this kind of MCQs wrong. Like, they would not convert kilometer into like meters, or meter into kilometer. They would convert minutes into hour, or the biggest mistake that they make is that they don't see that they are asking about average velocity, not average speed. So you have to be really clear about this kind of thing, like what are they asking about? Are they asking about speed, or they are asking about velocity? If they were asking about average speed, then the whole MCQ would have been different. So what could have been the average speed? Then we would have added 8 kilometer and 6 kilometer, and we would have gotten 14 kilometer, the total distance, right? And the answer would be completely different from this question. So that was about the first question from our past papers that you need to study, and now you know how these formulas are useful in IMAT exams. So you can use these short tricks in so many MCQs for IMAT exam. So let's move on to our next topic, that is about motion and graphs. Like motion and graphs is a minor topic in IMAT. Like there haven't been that many MCQs from motion and graph, but we are still going to do it. I'm going to tell you in advance. There are not going to be any graphs in IMAT. There is a really low chance that there would be graphs, but there could be concept from these motion graphs. Like there are like concepts that are related to motion graph. Like for example, they could ask you about what is the gradient and slope of displacement, what is the gradient or slope of for acceleration time graph. They won't be giving you direct graphs, they will ask you questions about graph, because the IMAT questions have shifted from diagrams to statements. Like there are not many diagrammatic questions in IMAT, but we are still going to be discussing and covering this topic because we don't need to leave any concept behind. So the first thing that you need to know about motion and graphs is that there are three types of graphs that we'll be discussing. The first is displacement time graph, velocity time graph, and acceleration time graph. So what is a graph? A graph is simply knowing what is happening between two variables. For example, if you need to know how much speed you are going through, so what you will know that you will see that how much distance you have covered in how much time. So the graph will tell you the speed for distance using distance and time graph. So the gradients of different graphs are written in front of you. You need to memorize them, but I will give you a shortcut to memorize all of these graphs. But first of all, let's study the table in front of you. So the displacement time graph, the gradient of displacement graph is velocity, and the gradient for velocity time graph is acceleration, and the gradient for acceleration time graph is nothing, like it is rate of change. The reason is we will discuss about it in our next topic. So what is gradient? Gradient is also called as slope. The formula for slope is delta y over delta x, like x component divided by y component, or it is also equal to tan of theta. Why is it equal to tan theta? Because it is simply math. So math tells you about these slopes. You will like learn these formulas in detail in your mathematics lectures, but we will still discuss it in maths in our physics lectures. You know, math is not going to leave you. Even like doing medicine, you will still need to study a bit of physics, a bit of mathematics, but not that much. Surgeons need to study mathematics and physics in some areas, but yeah, it is not that important, but still. So as you can see, the slope is equal to y component divided by x component. So if you see that if you draw distance and displacement graph, displacement and time graph, what is on the y-axis? It is displacement, and what is on the x-axis? It is time. Let me ask you, what is formula for displacement over time? And you will like, yeah, obviously it is velocity. So that's why the slope for displacement time graph is velocity, as you can see here. What if I change the scenario? Like if I write down time here and then I write down velocity here, what would be y component and what would be x component? The y component is velocity, right? And what is x component? X component is time. So what is velocity divided by time? It is acceleration. Acceleration is change in velocity divided by time, right? So that's how you can find the gradient for all of these MCQs. You have to be really clear about like what is the gradient and what is the graph. What if I ask you what is the slope or gradient for distance time? Yes, it would be speed. The gradient or slope for displacement time is velocity, and for distance time it is speed. And now you know what is what for these kind of questions. So let me write it down for you first. So if you have distance time graph, the slope would be velocity, and if you have velocity time graph, then the slope would be acceleration, right? You can also say the slope, or you can also say gradient. So what about the area under the graph? If you talk about the area under the graph, you can just reverse this shortcut formula like this. The area under the acceleration time graph is velocity, and the area under the velocity time graph is equal to distance. Like if it is velocity time graph, let me write down for you. If it is velocity time graph, and if I see the area that is under the slope, what it is this area telling you? This area is telling you that how much distance have been covered. So if this graph is measured, if this area is measured, you will know that if someone is going with really high speed and if they are covering specific amount of time, then this graph has covered amount of displacement. So for velocity time graph, the area under will tell you about displacement. What about acceleration time graph? Like this is acceleration and this is time, and under this slope, the slope is obviously velocity, right? Sorry, the area is obviously velocity. The area under acceleration is velocity, right? It will tell you about how much speed or how much velocity is for that graph. So the area under velocity time graph is velocity. So now you know all the graphs and all the things that you need to know about graphs. It was really easy, and this shortcut formula is everything that you need to know. Like, let me make it down for you. So this is the shortcut formula, memorize it. The slope for distance time is velocity, and the slope for velocity time is acceleration. The area under acceleration time is velocity, and the area under velocity time is displacement. And if you are thinking about what is the slope of acceleration time, there is like no slope or gradient for acceleration time graph. It is simply rate of change. And if you are thinking about what is the area of displacement time, like there is no standard meaning, like you don't need to know these concepts, like they don't exist, right? So what about the motions that will be discussed here? So before going into the motion, you have to know about what is slope telling you about. Like we are discussing about slope and all of that. What is actually slope? Let me tell you what is slope actually mean. If it is displacement and if it is time, and it is the slope. As you can see, this is a graph, and 1 2 3 4 5, 1 2 3 4 5. As you can see, with 1 meter and 1 second, this is the slope, and for 2 meter and 2 seconds, this is the slope, and for 3 meter and 3 seconds, this is the slope. So this slope is telling you how much distance is being covered in how much time. So that's why this slope was called velocity, because this slope is telling you how much displacement is being covered in how much time. So graphs are really useful tools to study the motion, because graphs tell you everything about what is happening and how the body is moving. Like we will discussing it in a really great detail. So these are the basics that I just told you about. So let's go into a greater detail. So first thing, that what is slope, when it is positive and when it is increasing, because there are two aspects for the slope, and the most students don't get when slope is increasing, when the slope is decreasing, and when slope is positive and when slope is negative. So this is really important, and I will be discussing it in really easier manner. For example, if I ask you what is happening in this slope, like let's call this slope as z, whether it is increasing or decreasing. Take your time and give me your answer. If you said that the slope is increasing, then your answer is wrong. The slope is actually decreasing. And if I ask the same question, whether the slope is positive or negative, then think about it. If you thought about like the slope is positive, then your answer is actually right. And if I make another slope like this, and we can say that the slope is, for example, a. So if I ask you what is the slope doing, like whether it is increasing, whether it is positive, whether it is negative, if you think about if it is decreasing, then you are wrong, it is actually increasing. And if you thought that it is positive, then you thought right, it is actually positive. Let's take other examples too. For example, if a slope is moving downward like this, and let's say this slope is called x. This slope is called x. Now tell me whether it is increasing or decreasing, and whether it is positive or negative. If you thought about it is decreasing, then you are wrong, it is increasing. And if you thought about it is positive, then you are again wrong, it is negative. I know that you are getting all of these kind of MCQs wrong, but at the end I will give you a shortcut about how to learn these things. Let's make another slope like this. Let's say it is y. So now think about it, whether it is increasing or decreasing. If you thought about decreasing, then you thought right. If you thought about positive, then you thought like wrong, because it is negative. So like these are really confusing things, right? Like you are really confused right now how to memorize these things. So let's make it easier for you. So the slope would be positive if the y component is increasing. Simple. If the y component increase in any way possible, then the slope would be positive. And when will the slope will increase? The slope will increase if the curve is towards 90 degree. Let's use these example in our the graphs. For example, let's take x first. Let's talk about x. No, let's talk about a first, like we discussed about a, right? So for a, let's say whether it is increasing or decreasing. As you can see the curve here, the curve is moving upward, right? It is moving towards the 90 degree, right? What is 90 degree? Like this. Oh, like this, right? Anything that is coming closer to 90 degree will tell you that the curve is towards 90 degree, then that means a is increasing. Simple, right? What about z? As you can see, the z was straight from the start, and then slowly it started going away from 90 degree like this. You can see z is going away while a was going towards 90 degree, right? So that's why a was increasing and z was decreasing. What about the sign conventions? For the sign, we said that if y component is increasing, then the slope is positive. As you can see, what is y component, right? This is the y component, y component, y component, y component. As you can see, a and z, for both the y component is increasing. For a and z too, for both of these the y component is increasing. So that's why for a it is positive, for z it is also positive. Fun, right? Like for at the start it was like what the hell is happening, and now it is like wow, it is really easy. Let's talk about x and y. If you can see x, if we make 90 degree again, x is curving towards the 90 degree, as you can see, right? So x is curving toward 90 degrees, that's why x is increasing. Wow. Let's talk about y. As you can see, y is going away from 90 degree like this, so that's why y is decreasing. Y is a bad boy, he is not curving towards 90 degree, he is going away. That's why the slope for y is decreasing. What about sign conventions? As you can see, the y component for both x and y is decreasing. The slope would be positive if the y component increases, but for x and y, for both they are going downward, right? So that's why for x and y, for both the slope is negative. Wow, It was easy, right? At first it seemed like really hard, but now it is like one of the most easiest concepts that you can learn about the curves and slopes and everything. So let's memorize all the things that we discussed about graphs here. The first thing that you studied about what is slope. Slope is y component, change in y component divided by x component, and it is also equal to tan of theta. So the slope for distance time, displacement time is velocity, for velocity time is acceleration, the area under acceleration time is velocity, and the area under displacement time or velocity time is displacement. So these were the shortcuts that we discussed about area and slope. The next thing we studied about was when the slope is positive and when the slope is increasing. If the y component is increasing like 1, 2, 3, 4, 5, if the y component is increasing, then that means the slope is positive. A and z both have positive slope. And if the slope is like y component is decreasing for x and y, then the slope is negative. If it is towards 90 degree, then it is increasing, and if it is away from 90 degree, then it is decreasing. So you have memorized all the concepts that you needed to know about the graphs. Like you can go for like any kind of MCQ and you will smash that MCQs. Believe me, you are ready to smash all the graph type MCQs using these simple shortcut formulas. So these were the shortcut formulas that you needed to know for physics. Let's do some examples, right? Without solving examples, what is the fun, right? You know, the first thing that the graph, as you can see, is simple. It is a straight line. It is not moving anywhere at all. It is a straight line like this. What does it mean? If it is distance, oh my god, if it is distance and if it is time, or you can say it is displacement, sorry about that. As you can see, if it is 1, 2, 3 and 4, and at 4 it is stopped while the time is increasing. 1, 2, 3, 4, 5, 6, 7, 8, the time is increasing, but while the displacement is same. That means like the object is still at its point, it is motionless. That means the displacement is 0. If the displacement is 0, then the slope is also 0, then the velocity is also 0 and acceleration is also 0, right? So it was not that hard. Let's do another example like this. As you can see, this is a straight line. If you can see it here, if the displacement is 1, the time is also 1. If the displacement is 2, the time is also 2. If the displacement is 3, the time is also 3. That means the slope is moving in a way that it is covering equal displacement in equal interval of time. As you can see, the slope is covering equal displacement and equal interval of time. Like for 1 meter the time is 1, for 2 meter the time is 2, for 3 it is 3. So as you can see, that means the displacement is equal to the covered time. Like it is covering equal displacement in equal interval of time. So the increase for displacement is uniform. So the displacement is uniformly increasing, right? And you can see the slope here. So the slope is constant, right? The slope is not increasing or decreasing, so the slope is constant. For velocity, it is also constant. If the velocity is constant, then that means the acceleration is 0. Why acceleration is 0? Because acceleration is change in velocity. So if the velocity is not changing, then the acceleration is 0. Simple. If we talk about something like this, like what the hell is this, right? Because as you can see, the time is still and the displacement is infinity. It is like an impossible kind of a graph because the displacement has a sudden increase. Like in the time was moving 1, 2, 3, and at the like 4th second the displacement was like 100 meters. Suddenly you covered 100 meter displacement. It can be possible if you move at the speed of light. For example, when you move at the speed of light, then the time stops moving. You can say like the time section stops, or you can say that time delays out. So this kind of graph is not possible in reality, but I just wanted to discuss it here. So you can say the slope for this graph is infinity, velocity would also be infinity, and acceleration would also be infinity. What about this kind of graph? As you can see, it is increasing, right? The graph is increasing. As you can see, it is moving towards 90 degree. So it is a non-uniform increase. It is increasing, but it is non-uniform increase. What about slope? Slope is increasing, velocity is also increasing, and acceleration would be positive, because velocity is increasing, then the acceleration would be positive. What about this graph? If this graph is, you can see it is going away from 90 degree, so it is decreasing, but it is a non-uniform decrease. It is decreasing non-uniformly. The slope is decreasing, the velocity is decreasing, and if the velocity is decreasing, then the acceleration is negative. So this was all about the displacement time graph.